So for the first, 6 problems on the classwork, the directions said to simplify. So we are simplifying these. Numbers 1 and 2, we're simplifying using the properties of exponents. The properties of exponents. So definitely be sure you've got the properties of exponents kind of close to you when you're working on this homework. So the first property that we're going to use is we're going to use the property that tells us to give this -3 to every single thing, including the numbers that are inside the parenthesis. Okay? Students very often will forget to give the numbers the exponent, and you have to give the number the exponent also. So we're going to have 2 to the -3 power. Then I'm going to have a to the -1 power times the -3 power. Because when I raise an exponent to an exponent, I multiply. Okay? That's what I'm doing when I raise an exponent to an exponent, a power to a power, we multiply. Then I have 3 to the -3 and b to the 4 times -3. Okay, now I know that sometimes you won't write out the -3 times or the -1 times -3 or the 4 times -3, and that's okay. I do it because I want you to see exactly what's going on. Okay, so we're going to simplify a little bit. So I've got 2 to the -3. Then I have a to the -1 times -3. So that gives me a to the +3. So that's going to stay in the numerator. My a will stay in the numerator. Then I have 3 to the -3 in the denominator and b to the -12 in the denominator.
That means it won't stay in the denominator.
Yeah, neither one of those will stay in the denominator, right? Okay, so now let's start moving things around. 2 to the -3. 2 to the -3 goes to the denominator, and that's going to be 2 to the 3rd power in the denominator. The negative exponent moves the expression to the denominator, and then your exponent becomes positive. My a to the 3rd stays in the numerator. Do you see my 3 to the -3 in the denominator? That's going to go to the numerator, and it's going to become 3 to the +3. Okay? My b to the -12th is going to move to the numerator, and that becomes b to the +12th. Okay? Now, if you left it like this, if you left it 3 to the 3rd times a to the 3rd, b to the 12th, over 2 to the 3rd, I would give you full credit. Okay? But 3 to the 3rd and 2 to the 3rd can be simplified. 3 to the 3rd is 27. So I have 27, a to the 3rd, b to the 12th, and 2 to the 3rd is 8. Any questions on that one? Okay. So let's look at number 2. Okay. I've got the -3 on the outside of the parentheses. So what that means is I've got to give that -3 to everything inside the parentheses, including the numbers. Okay. So I'm going to have 5 to the -3rd. Then I'm going to have x to the 3 times -3, because a power to a power, we multiply. So that's 3 times -3. Then I have y to the -2 times -3. Okay? So I'm going to do an extra step here. I've got 5 to the -3. What is 3 times -3? Good. So I have x to the -9th. Okay. Then I have -2 times -3. So I have y to the 6th. Now, I have 2 things that need to go to the denominator. What's going to the denominator?
5 to the 3rd and x to the 9th.
Good. My 5 to the negative third goes to the denominator, and once it goes to the denominator, it becomes positive exponent. My x to the negative 9th goes to the denominator, and it becomes x to the positive 9th. Y to the 6th stays in the numerator. Now, if you left it like this, I would give you full credit. 5 to the third is about as high as I expect you to go with evaluations, okay? With the computation. So y to the 6th stays in the numerator. 5 times 5 times 5 is 125. And that's 125x to the 9th. But like I said, if you stop right here, I'll give you full credit. Okay, I just had a 144 quiz, and there was a 7 squared on there. And I had about half of them leave at 7 squared instead of 49. And I gave them all full credit because of the type of problem they were doing. Okay? Can I go to the next one? Okay. Now, the key thing here is you realize there's nothing on the outsides of these that they're being raised to. Okay? I've got an expression multiplied by another expression. Okay? What number is in front of that a to the negative 4? What number? Good. Okay, there's a 1 right there. So what I'm going to do now is I'm going to multiply my 1 times my 3. Now, if either of those were raised to an exponent, I would need to deal with that first. But neither one of them are raised to an exponent. So I'm just going to do 1 times 3. Okay? Then I have a to the negative 4. And because I am multiplying a to the negative 4 times a to the first, what is my exponent rule? What do I do with those exponents? Good. So I've got negative 4th plus 1. Then I have b to the third power, and I have b to the second power. So then I have b to the third power plus 2, because I add the exponents. So I have 3 to the a to the negative 3, because negative 4 plus 1 is negative 3. Then I have b to the 5th power. What stays in the numerator? What stays in the top? Good. 3, because it doesn't have a negative exponent. And b to the 5th stays in the top because it has a positive exponent. A to the negative third moves to the denominator and becomes a to the third. Okay? For number 4, we are dividing bases. Okay? And when I divide, what do I do with their exponents? What do I do with their exponents when I'm dividing? Good. I'm going to subtract exponents. So for number 4, the first base that I'm going to divide is x. Okay, and I have a 3. And you want to be careful with this one because this is 3 minus negative 1. And minus a negative becomes what? A positive. Okay, then my y, I have a 5 minus 6. Okay, 3 minus negative 1 is going to be positive 4, because that's going to become plus a plus. 5 minus 6 is y to the negative first. 5 minus 6 is negative 1. Now my x to the 4th stays in the numerator. My y moves to the denominator. Do I have to put the 1 with that y? Do I have to do y to the first? No. I can. It's certainly fine if you add that first power there, but you don't have to. You don't have to. Okay? Okay. Is it okay if I go to the next screen? Okay. Number 5 is the square root of 48. Now, what students almost always do with the square root of 48 is they do 4 times 12 because 4 is a perfect square. And that is correct. 4 is a perfect square. What's the perfect square of 4? 2. And so students will do 2 on the square root of 12. The problem is there's a perfect square inside 12. What's the perfect square inside 12?
4.
Another 4. Okay, so then that's 4 times 3. What's the square root of 4? So then I would have 2 times 2 on the square root of 3. So that's 4 on the square root of 3. And it's fine if you do it that way, as long as you don't stop right here. Okay? If you look at that and you're like, okay, 12 has a perfect square in it, I'm going to keep going. Okay? You're okay. The best way to do this problem is to break 48, to have the square root of 48, and to break it up into 16 times 3. We don't always recognize that 48 is 16 times 3. What's the square root of 16? 4. So we have 4 on the square root of 3. So either way you do it is fine. The big thing is that you keep going when you get right here. That's the big thing. Okay? Okay. Now, we have the square root of x plus 3 and the square root of x minus 5. Okay? What process do I have to do here? What's that called when I have a binomial times a binomial? Good. I'm no FOIL. Okay? So I have the square root of x times the square root of x. And I'm going to write this out just so you can see it. Square root of x times the square root of x. Then I have the square root of x times negative 5. Okay? So I've got the square root of x times negative 5. Then I've got 3 times the square root of x. And I've got 3 times negative 5. Okay? Now I know that you might not write that out in the same way, and that's okay. The square root of x times the square root of x. Square root of x times the square root of x is the square root of x squared. What is the square root of x squared? X. Excellent. That's going to be x. Okay, so this is x right here. Then I've got negative 5 on the square root of x. And here I've got plus 3 on the square root of x. 3 times negative 5 is negative 15. Now, we didn't talk about this a lot, if we talked about it at all. But these are what we call like terms, so they can be combined. What's negative 5 and positive 3? Good. So this is going to be negative 2 on the square root of x minus 15. And sometimes in college algebra and stuff, you'll factor that, but not in this class. And we don't actually do it in 144 here. Okay? That one's kind of tricky. Now, in my opinion, 7, 8, 9, and 10 are kind of the bulk of what we're doing right now. So I really want you to be sure that you know how to do the next 4 problems. Okay? Can I move to the next screen? Okay, here we have the square root of 3x plus 1 equals 3. So in order to solve this, what I'm going to do is I am going to square both sides. I'm going to square both sides.
Which would be 9, and the other one would be 3x.
Good.
And then you would just subtract 1 to each.
Good. Yep, you're on the right track. Okay. So when I square the square root of 3x plus 1, I get 3x plus 1. Okay, and what is that equal to? Good, because 3 squared is 9. Okay, Now I'm going to subtract 1 from both sides, and I'm left with 3x equals 8. Okay. I divide both sides by 3, and my final answer here is x equals 8 over 3. Now, when we are doing these types of problems, you have to do a check, especially when you have 2 answers. But I would do a check always, because sometimes you get an extraneous solution or an undefined solution. Okay? So I'm going to do 3 times 8 over 3 plus 1 equals 3.
I'm guessing this is one of those undefined solutions.
It actually isn't. Okay? So 3 over 1 times 8 over 3.
Cross multiplication.
Good.
Okay, now I see here.
So now I have, what's 8 plus 1? 9.
And that would be the same thing.
Good. So does this one work?
Yes.
Good.
I'm sorry, I'm just feeling very...
You're fine.
I can't...
That's okay. You can put your head down if you need to. It's okay. Okay. Can I go off this screen? Okay. You definitely want to be familiar with this problem right here. You will see this on a test. So I've got the square root of x equals x minus 2. Square root of x equals x minus 2. So the first thing I'm going to do is I'm going to square both sides. The square root of x times the square root of x, or the square root of x squared, leaves us with just x. But what am I going to have to do here? What do I have to do there? Good. I have to FOIL. So I have x minus 2 times x minus 2. Okay? X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. Okay? So I have x equals x squared minus 4x plus 4. I need to set it equal to 0. So I subtract x from both sides. I get 0 equals x squared minus 5x plus 4. Okay? Now I want to factor that, and it does factor nicely. Okay, what 2 numbers multiplied together give me positive 4, and added together give me negative 5. Excellent. Negative 4 and negative 1. So when I put each one of these equal to 0, I get x equals 4 and x equals 1. Okay, but we have to make sure the check works. We have to make sure the check works. Okay, so I'm going to check 4 first. So I've got the square root of 4 equals 4 minus 2. Okay, the square root of 4 is 2. What's 4 minus 2? 2. Okay, does it work? Yes, it works. So the 4 works. Okay, now I need to check the 1. So I have the square root of 1 equals 1 minus 2. What's the square root of 1? Okay, what's 1 minus 2? Negative 1. Does that work? No, it doesn't. And I did not put on my answer sheet that it doesn't work. So I'm sorry about that. So on the I don't know if you looked at the solutions or not, but I didn't mark out that the 1 didn't work. So my only answer to this one is x equals 4. The x equals 1 has to be thrown out. Okay? Now, I also included 2 quadratics just to get you thinking about quadratics. I'm in a race against the battery life on my iPad. So we're going to do it. I'm going to make it. Okay. X squared minus 2x minus 1. We actually did this exact problem in class today. Okay? Remember, it's dangerous with that negative 1, because if it was a positive 1, it could be factored. But with the negative 1, it can't be. Negative 1 times negative 1 equals positive 1. And we've got a negative 1 here. This is a great setup for completing the square. So I have x squared minus 2x, and I'm moving that 1 over. Okay? I'm going to take half of negative 2. So 1/2 of negative 2 is negative 1. What's negative 1 squared? What's negative 1 squared?
1.
Good. Okay, so I am factoring this by design. It's a perfect square trinomial. I take the square root of both sides. Don't forget that plus and minus. When you take the square root of the right-hand side, you want to be sure that you do the plus or minus.
X minus 1 equals plus or minus the square root of 2.
Good. Okay, so I'm going to have x minus 1 equals plus or minus the square root of 2. My next step is to add 1 to both sides. So my final answer is x equals 1 plus or minus the square root of 2. Now, I could have done the quadratic formula on that. I like to do one of each. I could have done the quadratic formula, and that would have been good. But completing the square works nicely. We're going to do the quadratic formula on the next one.
Negative b plus or minus square root of
You're good.
b squared.
Okay. Can I go to the next screen? Good. Okay. Okay. So it's negative b plus or minus the square root of b squared minus 4ac divided by 2a. I never know if students like the colors or don't like the colors.
I think they're helpful.
Do you think they're helpful? Okay, good.
Even if I don't like do my testing colors, it's still helpful.
Oh, good.
Learn it.
Yeah.
Good. Okay. And I do have one student that wants colored pencils and highlighters when she takes her test. I'm like, hey, whatever you need. Whatever you need. Okay. So now I have my A value is going to be 3. My B value is negative 2. And my C value is negative 3. Okay. So I have negative 2. Okay. Uh-oh. Plus or minus, I just got the battery alert. Plus or minus the square root of b squared.
So it would be 4.
It will be. You're correct. Okay, and then I have A is 3. C is negative 3.
Positive 36.
Mm-hmm. All over 2 times A. A is 3.
I always forget. Do we have to simplify if it's? I always forget that part. Can we simplify if we can, or do we not?
Yeah, you do want to simplify if you can. You do want to simplify if you can.
Well, I mean, like since it's like over something.
Since it's over 6, we are going to have the opportunity to simplify this, yes.
Okay, thank you.
Okay. Negative 2 is going to be positive 2. Plus or minus the square root. Negative 2 squared is positive 4. That's a place that sometimes students make mistakes. Negative 3 times 3 is negative 12. Negative 12 times negative 3 is positive 36. We're going to end up with 40 in there. And we've had to simplify 40 a couple times. 2 times 3 is 6. So I've got 2 plus or minus the square root of 40. Okay, and we know we've had to simplify 40 before. What do I break it down to?
2 square root 10.
Okay, but before that.
4, 10.
4 times 10 inside the square root. Now we can take the square root of 4. So I get 2 plus or minus 2 on the square root of 10 over 6. Okay, if you get to this point right here, I'm going to be super happy. It can be simplified one more. Well, actually, I meant this one. If you make it to this one, I'm super happy. Okay? If you make it to the next one, I'm ecstatic. Now, 2, 2, and 6, they all can take a 2. So I'm going to have 1 plus or minus 1 on the square root of 10 over 3.
So it would just be 1 plus or minus square root of 10.
Over 3. You got it.
Okay, that was it.
Yes. That's it. Okay? You're good. You're good.
All right.